Now, reference angles are a little different than coterminal angles. Reference angles are formed, basically think of them as absolute value. Reference angles has to be a positive number. Has to. So if you get a negative number, you just need to take the absolute value of it and make sure it's positive. It is also the smallest angle, acute angle, that is formed from the terminal side, which we've already talked about, to the x-axis. Never, ever, ever the y-axis, only the x-axis. So for example, if you're in quadrant 1, the reference angle is going to be the exact same thing as the standard angle. 45 degrees, 60 degrees, 50 degrees, no matter what, because it's acute. It has to be less than 90 degrees. That's what acute means, less than 90. So that changes nothing. However, in quadrant 2, to get to this standard side, like let's say this is 120, that would be the standard angle. But to get, again, you want the smallest positive acute angle that is referenced to the x-axis, which means if you would take this terminal side, that means you want to know the shortest distance from the terminal straight down to the x-axis on this side. So this, in this case, would be the negative x-axis. But again, you're wanting to know the shortest distance to the x-axis. You wouldn't go that way. You would go the shortest route, which is straight down. If you're in quadrant 3, you would go back up to reach that x-axis. And if you're in quadrant 4, you would go back up to reach that x-axis. So again, it's positive, which means you need to take the absolute value. And if it's in quadrant 1, they're the same angle, no matter what. But the moment you get into quadrant 2, 3, and 4, you're wanting to get that angle that is referencing from the terminal straight down to the x-axis. So if you notice, it is also automatically going to be acute, and we're going to be subtracting from that point. And let's see how you actually figure out how to subtract. And here's how you do it. If the reference angle is in quadrant 1, it's automatically the same angle. But if it's in quadrant 2, they're going to do 180 degrees minus the angle. Because why? This is 180 degrees from here to here. So if I am going somewhere here, I need to go 180 degrees back up to that quadrant or to that terminal side. If it's in quadrant 3, then you're going from the initial all the way past 180 degrees. So this is where you would take the angle, which is going to be higher than 180. So for example, 200 degrees, okay, is in quadrant 3. So to reference 200 degrees, which is about here, and you're wanting to go back up to the x-axis, then you would subtract 200 minus 180, which will give you 20 degrees. You're wanting to just go back up to the x-axis. That's the whole point. You're trying to get to the x-axis. And if you're in quadrant 4, then you've gone so far away around the circle that the only way back to the initial side is to subtract from 360. So now, it's hard to remember. Basically, if you think of it, if you're in quadrant 2 or 3, you're subtracting from 180. If you get a negative, just make sure it's positive. If you're in quadrant 4, you need to subtract from 360. Just make sure it's positive. Now, how do you know which quadrant it's in? Because sometimes you don't necessarily even know. Like if I said 300 degrees, like would you know what quadrant it would be in? So here's how you need, what the first things that you need to memorize. When you're on a coordinate plane and you start at 0 degrees, because that's the initial side, and if you go 90 degrees, you'll have reached the y-axis. If you go another 90 degrees, you've reached 180. Another 90 degrees is 270, and the other 90 degrees is back to 360. You need to be able to know these angle measures by heart. If it is a radian, this is where it gets a little more interesting. If you start at 0, just like you start here, nothing changes. And we know that halfway around it's pi degrees because we know that the convergence factor is pi over 180. So where 180 degrees is the diameter of a circle, you're going halfway around the circle. That means you went pi around the circle. So if halfway around the circle is pi, that means up here it is going to be 1/2 pi or pi over 2. And then if you go 3 halves around, no, 3/4. Sorry, if you go 3/4 of the round, it is 3/2 pi, because again, 1/2 plus 1/2 plus 1/2 is going to be 3/2. And then when you make it full circle back around, it is going to be 2 pi. So reference angle, first you have to figure out where 150 degrees is. So if you think of the unit circle, not unit circle, but if you think of a circle that is cut by the coordinate plane, this is 0, this is 180, 90, 270. So 150 degrees is going to be right here. It's between 90 and 180. So quadrant 2 means you subtract from 180. So therefore your answer is going to be 30 degrees. So in this case, negative 300. Here's the problem. You first need to find a coterminal angle to get it inside 360 degrees. So first find a coterminal angle. So take negative 300 and add 360 degrees in order to get it inside this. So if you do that, you actually get 60 degrees. 60 degrees is in quadrant 1, so automatically it's going to be the exact same answer. So I want you to try these two down here on your own to see if you can figure out what those reference angles should be. So 280 is going to be down here in between. No, it's not. 280 is more than 270, and so it is going to be in quadrant 4, which means you subtract from 360. So therefore, your answer is going to be 80 degrees. Because again, you're going from that terminal side back up to the x-axis. And then 35 degrees is in quadrant 1, and so it is just going to be the exact same answer. Now, for a reference angle, this is where it just gets a little squirrely. So one thing I'm going to go ahead and just tell you the trick and then explain why it works. The reference angle is always going to be pi divided by the denominator. Always, 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 always. The denominator is 3, so it's pi over 3. The denominator is 4, and so your reference angle is automatically going to be pi over 4. Your denominator is 6, and here your denominator is 3. Automatically, your reference angles are going to be pi over 6, and the reference angle is going to be pi over 3. Positive, not even negative, even though it's negative. Now, here is why that works. All right, we have our coordinate plane. Okay. So we know that this is pi, right? And we know this is pi over 2. But we need to know what it is with a 3. So if this is pi and we have a denominator of 3, that means this is 3 pi over 3. And half of that means half of 3 is 1.5. So 2/3 is going to be between 1/2 and 3. So 2/3 is going to be in this direction. And so to subtract 3 pi over 3 minus 2 pi over 3, 3 minus 2 gives me pi over 3. 5 pi over 4. So if you think of it again, if this is pi, but we need to have a common denominator of 4, then this is going to become 4 pi over 4. Half of that is going to be 2 pi over 4, and halfway of that is going to be 6 pi over 4. So 5 pi over 4 is going to be here. So to get it back up to the angle, we're just going to subtract 5 pi over 4 minus 4 pi over 4. 5 minus 4 is 1/4. It happens with every single denominator, no matter what. Whatever your denominator is, it's automatically going to be pi over that number. So reference angle for radian is actually a whole lot easier than finding the reference angle for degree.